primer simposio en Ciendre, lo digo porque me suenan algunas caras. Sabéis que hace 2 años, cuando presentamos esta iniciativa, con mucha incerteza, porque no se sabía si iba a haber financiación, si no, y de hecho hubo una interrupción en la financiación que hizo que el año pasado no se pudiera continuar. Pues sabéis que lo presentábamos un poco con la idea de cómo somos capaces de movilizar a los científicos de COSCE, que nos consta que en muchos casos, en la mayoría de los casos, tienen alguna actividad de divulgación o transferencia de conocimiento muy activa y en muchos casos involucrando a las escuelas, cómo podíamos aglutinarlos de manera que estas actuaciones no fueran aisladas, de carácter personal, de tiro personal, y se conocieran poco desde la comunidad educativa. Como muy bien ha presentado José Miguel, la intención nuestra era, sobre todo, ayudar a los científicos que están haciendo estas iniciativas a hacerlas de una manera que fueran más útiles para el profesorado y, por otro lado, que el profesorado se sintiera acompañado y ayudado por los científicos. Hoy tendremos tiempo durante el día de hablar de esto, pero sí quería ponerlo en contexto para que se entienda el contenido de las 2 charlas que vamos a tener esta mañana. La primera charla, que es de Sara Tougaard, yo la voy a presentar. Sara Tougaard hoy en día es la directora del Aquarium Nacional de Dinamarca, pero durante muchos años ha sido la directora del programa de formación de profesores del Experimentarium, que es yo creo que decir museo científico se queda corto para lo que es el Experimentarium. Seguro que os suena la iniciativa original de San Francisco. En Dinamarca también tienen un parque muy parecido y son de estas iniciativas de divulgación que tienen mucho éxito y mucho impacto en el lugar en el que se hacen, porque se hacen desde el conocimiento, no solamente de las ciencias, sino de la didáctica de las ciencias, de la enseñanza de las ciencias. Sara, en su formación, trabaja además como profesora en la Universidad de Copenhague en 2 departamentos, el de comunicación científica y el de etología. En su formación ya me comentaba que, aunque no es científica, lleva muchos años, como veis, en el ámbito de la comunicación de la ciencia. Y su charla de hoy va a ser un poco orientada a cómo hacer el trabajo práctico de las escuelas más efectivo. Yo le comentaba a los ponentes de hoy que la mayor parte del público son científicos que están interesados en la divulgación científica. Entonces, este tipo de charlas creo que pueden ser interesantes para que nos hagan reflexionar en cómo hacemos nosotros nuestras actividades de divulgación. Es decir, cuando nosotros vamos a hacer una actividad de divulgación a una escuela, estamos haciendo un poco de maestros. Y es especialmente importante que la manera en la que comunicamos, la imagen de la ciencia que comunicamos, sea útil. Y Sara nos va a hablar específicamente de esto. Muchas gracias, Sara. La ponencia va a ser en inglés, pero tenéis, si alguien lo necesita, el traductor simultáneo. Muchas gracias.
No, let's see if it works. Primero, lo siento que no estoy capaz de hacerlo en español, pero si hay preguntas, podéis hacerlo en español, que entiendo muy bien, but I speak English better. So, I find it very awkward to be sitting addressing you, so I will use this microphone. If I have a tendency to lower it, you can just signal to me. So I'm here, and I'm very delighted to be here. I've lived in Spain for some periods in my life, first in Barcelona and later in Salamanca and here in Madrid. So I have a great affection for Spain, and I'm happy to be back. But I'm here to talk to you about the Method Lab, and that's a scientific inquiry and practical work in school, not iSchool, in schools. And now I will try and manage both a microphone and because first of all I would like to introduce myself, so you have a picture of my platform, so to speak, where am I coming from, and what is my background. My name is Sara Tougaard. I'm right now a head of education at the National Aquarium. We just opened a new aquarium in Copenhagen, a huge aquarium, quite similar to the one in Lisbon, if you've ever been there. And there was a vacancy as a head of education, so I couldn't resist. I had to take the offer. But I was quite... My formal background is found in the University of Copenhagen, where I studied first ethnology and then later communication and education, communication. And while I was studying, I also studied at the University of Roskilde, and I worked at the zoo. I was an explainer, a teacher at the zoo. Then later I got the position at the experimentarium, where I made this project together with some of my colleagues. And I now have the position in what was known as Denmark's aquarium, and it is now known as the Blue Planet, because we moved the Denmark aquarium was quite small, and now we build a new one as the Blue Planet, and that is where I'm working currently. But this project has its origin in the experimentarium. And the reason why I put University of Southern Denmark here is that I'm an extern lecturer at the university as well. So I have quite a patchwork of jobs behind me. Well, the next 45 minutes or so, I will be explaining to you what is Method Lab and why is Method Lab. So the two fundamental questions that I will be addressing. But to give you a sense of the content, the context in which Method Lab is found, it has, of course, to do with the state of science education in the whole of Europe, but of course it's quite specific to Danish, the Danish society. So I will give you a very short description on how science education is in Denmark. The subject science in the grade in the primary school, it is this is very difficult. Science is a very small and a very large school subject. It's small in numbers of lessons, and most of the years the students have only got 1 hour of science a week. But if you look at the curriculum, it's massive. There's so much content that the students need to learn in very little time. So that's a challenge. No, it doesn't seem to work. So, and another problem that may surprise you, but science teachers in Denmark, they lack formal education in science. They do have formal education in teaching and in teaching language or other subjects, but only 30% of the teachers doing science classes do have a formal science education. This number may have increased because it's a quite old figure. I think it dates from 2001. Oh, perfect. I'll keep this one if this one fails. Okay. So, now I have both hands free. That's much better. Okay. As I said, the number 30% may have changed, may have increased, but it's still alarming that so few teachers has got formal education in science. And of course, the Danish society is, like all European societies, very much aware that the interest of in science is decreasing very much within the younger population. This is also changing. I just read some surveys on attitudes amongst young people, and even though Denmark is not so badly struck by the crisis as you are here in Spain, then the Danish young people leaving high school, they express very much more anxiety and concern for the future. And even though it's a bit brutal, it may be a window of opportunity for science, because they try to figure out what should I do with my life. Maybe a career within media is not so safe anymore. Maybe I should turn to something safer. So that could be a window of opportunity, even though it's a sad one. You have this Rochard report again, and of course MethodeLab is also a child of the thinking of the European Union put down in the Rochard report. And the Fibonacci project and the Pollen project are quite in the same league as MethodeLab. MethodeLab is funded by a private Danish foundation, quite similar to CaixaBank or some of the other bigger foundations here in Spain. So we have got no EU fundings, but the project is very much similar to what you would see in the Pollen project or in Fibonacci. So moving on, what is MethodeLab? MethodeLab is Teachers' Continuous Professional Development, formerly known as teacher training. But I've been told that teacher training is not something we do anymore, because teacher training has got this feel that you can train the teachers as if they were animals. So, so now we talk about the continuous professional development. And you can see some pictures of the many courses that we have held. This is me upside down almost. And I'll give you some examples later on what we actually did on these courses. This is the underlying theory of MethodeLab. And even though it's in Danish, I have a feeling that you get the idea. What is this trying to illustrate? The circle is a very rough description of a scientific method, which will ideally start in a question. Somebody wakes up in the morning and I wonder what size, how big is the Earth, or is the Moon closer to Earth now than it was 2 years ago, or whatever question that may arise. And then you formulate a hypothesis, or you have a guess that would guide you in a certain direction, and then you rely on your methods of investigation or inquiry. And then you do your inquiry, and then you interpret your data. What have I found out? And you have a conclusion. Or maybe you have a new question, depending on how well you did your research. This circle is not new to Danish school teachers having science education or no science education. This circle is known to them. Danish teachers are very keen on getting pupils to ask questions and to find out for themselves. They very much like to do that, and they do it well, but they do lack a few skills in doing it properly. So what we thought in the MethodeLab when we were given 7 million kroners, which is a huge amount of money, was that we do not need to teach the teachers to do this kind of work, to do inquiry in school. But what they lack is a sense of the differences between the methods that you use in science. Because if you're not aware of that, you eventually end up just Googling it, look it up on the Wikipedia. But if you really want to find out for yourself, then you need to scrutinize what kind of question have I posed? So what investigation method would be appropriate? So what we suggest in MethodeLab is that we make a didactical breakdown on the method. And we pointed out 5 sub-methods. And in real science, they of course intermingle. This is meant to be used in school, where you didactically break up the content to make it teachable, to make it accessible for the children. So we argue that you could make 5 different methods of investigation. Modeling has nothing to do with catwalks, but scientific models, trial and error, see what happens, observations, document-based research. You could, of course, make a review, read what articles is there to be found on the subject, what have others found out about my question, or you can just simply look it up on Wikipedia. You can ask your teacher, or you can ask a professional. And then, of course, you can do the experiment, or what I would call a fair test, where you really is very anxious about keeping everything in control, that if you're studying the connection between the amount of patatas fritas eaten and the size of your tummy, then you should only eat patatas fritas and nothing else, and then do it for a week, and then try to figure out, did you do any exercise in the period, or what could be a bias. And of course, you being scientists, you will perhaps you would argue that they intermingle, and they sure do. And for instance, observation, you can't do any of the others without observation, because observation is to block out what is irrelevant and only focus on what data do I want from this. But we do argue that making it visible for both teachers and pupils that you work in different ways, then the practical work will be easier, and the planning of the lessons will be easier. I have no idea of the time, so I'll just take out my mobile phone. I know it's impolite, but I need to know how I'm doing on time. Good. I'll give you a few examples so you can get an idea of what we did. How is it done? Observation. This is an example from one of the teacher training courses or the further professional development courses. This is a teacher scrutinizing a cockroach. What we asked the teachers to do at the course was to use 5 minutes in a circle and then make close observation of this cockroach, and they even took it out of the cage. And we asked them to tell us what they saw, what they felt, what they heard, what they smelled, because observation can involve all the senses. So we emphasized that they should tell us everything. And then we just filled a blackboard with all the data. And then later we tried to systemize the data. What kind of data have we got here? And then it was quite obvious that we had a lot of data on the animal's morphology and a little data on its behavior. But that was about it. And it was obvious for the teachers that they now had so many questions that they would like to find answers to. What does the cockroach prefer, moist soil or dry soil? Where does it live in a group, or is it a solitary animal? So there was an opening for other ways of looking at this animal, and it was done through observation. And when we discussed the activity with the teachers, we did not discuss the cockroach. We only discussed how was it to do an observation on an animal. What could you find out, and what was the limitations of doing observation, and what was the strong points. Now, when I'm at the aquarium, we have many classes coming to the aquarium on their own or with their teachers, but just being on their own. And many of the children are well prepared. They have formed questions that they want answers to at the aquarium. So just the other day I met 2 girls. I was in uniform, so they asked me, please, can you help us? And they had these questions. And what they had was, how many youngsters does a shark get? where does this and this animal live? So they have questions that were ill-fitted to the aquarium. They only had questions that they could find answers to if looking it up on the internet. They did not have any questions that they could where they could find out for themselves by looking at the animals. So I had to show them where the signs were, so they could read the sign and then find the answers to the questions. And that's a pity, because if the teacher had been aware that going to an aquarium or to a zoo, that entails that you can do observation. So you should formulate questions that can be answered by observation and not by document-based research or simply looking it up. So that's one way of making it clear that at some points observation is what you can do and what you should do. Oops. And then we also discussed models. And doing models is something that is more and more done in science, and some parts of real science is nothing but modeling. I think CERN in Switzerland is being one big model. Of course, it has to do with the natural world, but it's so complicated and it's so arranged that it is in fact a model of the real world. So what we talked to the teachers about, and this is where one of the points where I think me and Maria's talk will fit together nicely, is to talk about what do you need to know in order to find answers to your questions in a model. Say that a child has a quite simple question, where is Africa? And then the teacher say, well, you can take a look at this globus, and then you can find out where Africa is. That's quite abstract if you're only a first grader. I mean, Africa is a place where lions roam and giraffes. And then the child is asked to look at this quite ugly globus to find out where is Africa. It takes a lot of, what's the word? Abstraction. You need to be able to think out of the box and to understand that this is in fact a representation of the real world. So what we are looking at here, the green spot is not green in reality, it's just green in order for me to see it better in contrast to the other countries. So the color of the countries is only for me to read it better. It may not have anything to do with the climate in the specific countries. And then in other models, the colors are very significant, and then you need to be aware of the colors. So simply getting familiar with how demanding it can be to find answers to questions in models, that was very interesting. And you can see some teachers discussing a model of a rocket, and this is in fact a rocket, because it can fire with water and pressure. And the circle of the water, this was very heavily discussed, because these arrows, do they exist in real life? What are these arrows? They could discuss it on and on. And then we did the FAIR test, or the experiment, and the case we gave the teachers was what is the single factor, the size of a soap bubble. What is the most conclusive single factor deciding the size of a soap bubble? And so they had to make a test. Is it the size of the soap bubble maker, or is it the components of the soap bubble water? Is it the technique in which you make the soap bubbles? And of course they had to do it fair, so they couldn't test more than one thing at the time. And then they also had to figure out ways of measuring a big soap bubble. How do you measure a soap bubble? So that was done in different creative ways. The teachers found the FAIR test quite challenging quite daunting. It was difficult for them, and they said that they thought that the pupils would find it difficult as well. But in my opinion, the FAIR test can quite easily be used with the younger children, because I once, in my very young teens almost, looked after Spanish children in Barcelona. And one of the things I learned fastest was, no es justo, que no es justo. They're very aware that he got 2, and I only got 1. And that's not fair, because you did like that and I did like that. So they are quite observable about was it done properly, and you can activate this sense of justice that they have in the younger grades and make it into science and a game as well. The last one is trial and error. Just have a go and see what happens. And the question could be, I wonder how strong is a balloon? What can, because normally they break quite easily, but sometimes they never break. You can sit on it and it won't break. So I just brought some balloons because I thought maybe there would be a table or something here, but there's nothing. But I'll demonstrate to you what we did. We blew up a few balloons. And then we placed them on the floor. Maybe 20 or 25 balloons. And then we took a table and turned it upside down and placed the table on top of the balloons, and then you get a platform. And then we asked the teachers to step up on this platform. You can see it being done here. Some of them are not so sure it's going to work. And then they found out, oh wow, they won't break so easily. And then we gave them a challenge. How few balloons is necessary if you need to have two persons on the table, or this is just a plate, but you can do it with a table. And then they started not to experiment, but they simply tried to see what happens if, and they had, you can see this group. It's a big chaos. They were having so much fun. This group, he is in charge. He's deciding what to do. So there are very different ways of approaching this task. And the teachers, they loved it. Of course they did. But what we did afterwards was that we asked them, what do you now know about balloons and about tables? And then they start to formulate different observations on what they had seen. And we also tried to emphasize the way they had worked here, because none of the teachers had ever tried to combine a table and balloons. It was completely new for them that it could be put together. But still, when we gave them the task, they just went ahead and tried to do something. So we, in this method, we emphasized that of course, they had tacit knowledge that they used. They had already small bits of hypothesis. Well, I've seen in television, and if you need to lift up something heavy, then you need to place it in one of the corners. And this was the way that many of the teachers would start off with the balloons all the way around. And then slowly they would find out that one balloon is enough. It just needs to be placed right and in the center, and then you need to have a good choreography in getting up. You need to coordinate. So what we made visible for the teachers was that they were formulating ideas and hypotheses, drawing on what they already know when solving this problem. So it is also a way of working with your knowledge and gaining new knowledge and getting new questions on if we should carry on. How can how can we investigate further on the strength of balloons, or how can we investigate on the way pressure is being measured. So it gave rise to a lot of new ideas. So we have done MetodeLab in all of Denmark for 3 years, and it's still running. I'm no longer a part of the tour, but I'm still part of the group behind. And you can ask, is it effective? And it has been evaluated, the courses has been evaluated by the Danish National Evaluation Institute, and they sum up in the evaluation report. We get it all. Two major findings. The first one is a very positive evaluation of the course, which, according to the participants, teachers, has given new insights and inspiration. That's good. And then the second one. The second finding is that even though the teachers are positive, they express some concern in regards of implementing the concepts from MetodeLab in the daily teaching. And if any of you work in professional teacher development, you will know that this is the cornerstone of teacher development, because the transfer from being on a course with your colleagues and then being back in your classroom. So it didn't surprise us. Of course, we had hoped it would be different, but it didn't surprise us. But we know that at some schools, they now use the 5 different ways of doing experiments, the 5 methods, when communicating about progress in their classes, and especially when they hand over their classes in the 6th grade to the science teachers in the 7th grade. There's a division between 6th and 7th grade. Then they have discussions about which method has the pupils been working with. And another sign of efficiency, which makes me very proud, is that this small booklet that we made, we did not write it, we simply put together articles on the subject. This is now part of the curriculum in the teacher training or the teacher education. So the next generations of teachers will be very much aware of the scientific methods and how to work with them. And we indeed lack survey on how it influences the students. We have only made evaluation on how it influences the teacher. And that's, of course, a major drawback, and we need to look at that. So, one question may spring to mind: why this emphasis on scientific methods? Now I explained to you how we did it and how we tried to break it down in bits and pieces that makes it more teachable and makes it more manageable. And the reason why we emphasize scientific methods so much is also found in how science and practical work is viewed and used in Danish schools. If we take a look at the curriculum is divided for science in grade 1 to 6, but it's actually grade 0 to 6. It's central knowledge and skill areas. I can tell you it's very difficult to translate curriculum into English, but I'll try and do my best to give you a picture of what it's like. So we have 4 central knowledge and skill areas, one being the closed environments and the distant environments. Very bad translation. What is meant is the one cluster here, the closed environments, is to do with yourself. Your body, your surroundings, and the city, and transportation, and then the distant environment. Yeah, well, it starts with the solar system and then works its way inward. So that's a division that at some point was made in the ministry, that we have a close environment and we have a distant environment. And then there's one that's called scientific methods and skills. And then there's man's influence on nature. And I don't know, I really don't know about other curricula in the rest of Europe, but the social democratic governments in the 90s, they had a huge fingerprint on legislation in schools and making it more green, so to speak. So this is clearly an influence from that. So these four central knowledge and skill areas, they form the content of what is to be taught in Danish schools. And they are equal, they are at the same level. One is not more important than the other. But what surveys find among Danish teachers is that they look at it this way. When they plan their teaching, they look at the distant environment, the close environment, and man, influence, and nature, and they choose which subject to teach, and then they have the scientific methods and skills in the background. So they don't give the scientific methods a place of its own, because when they say, "No, we will do something about the life in the lake, and we will go and fish and see what we can find, and see if we can name some of the animals that we find." And then they will say, "Oh, that's brilliant, because that's a closed environment." And if we make the children take samples, well, that's a scientific method, so that's done as well. So the scientific method is not having a place of its own. It's simply just something that is being done while you're busy doing something with the other trees. And that we find in Method Lab is a huge problem. Because if you look at the didactical transposition, which I have taken from Chevallard in Winslow, I don't know how the sound of didactics is in Spanish. I know that in English, didactic has a bad feel to it. It again has something to do with training, and being didactical is being rude. But in Danish, didactic is from the German tradition, and didactics takes very much into account the learner and how the teaching subject, teaching content should meet with the life world of the learner. So didactics is not programming or just method. Didactics is very relational. The teacher, the content, and the pupil. That's the didactical triangle. So if you look at the transposition, and transposition is a term borrowed from music. So if you want to play a certain tune on one instrument and it's not written for this instrument, then you can transpose it. You can make a transposition so to make it possible to play this tune on another instrument. And Chevallard had used this metaphor in didactics. Because what is to be taught in science, that is to be found within the huge body of knowledge that is natural science. And then we have an external transposition, because this is university, it's huge companies doing research, and they provide us with the body of scientific knowledge. And some of that is taken out. And in schools, it would be the Ministry of Education that will point out what is to be knowledge that is to be taught. Because we can't teach them all everything about science. So we need to have an external transposition, somebody deciding on what should be taught in schools. And this will then be the curriculum. And then we have the teachers, who now has to perform the internal transposition. And maybe it's exceptional in Danish schools. I know it does not apply in France, but in Denmark, the teachers has got a huge amount of freedom in deciding how to perform this internal didactical transposition. I know that in some part in France, the Minister of Education can know that today is Thursday, it's 5 o'clock. So now all 7th graders has something with the solar system, because that's on right now. Every child in France is now learning about the solar system. It doesn't apply in Denmark. In Denmark, the teacher is in charge of the eternal transposition. Of course, the teacher will rely on school books that would have done this internal transposition and made it into knowledge that is to be taught. Down here, of course, this is what the teacher is doing, and then down here we would have what has the pupils learned, but that's outside the model. So this is a model of didactical transposition, and if we look at the curriculum for the Danish schools, then we will find here in knowledge to be taught scientific knowledge and scientific methods, the 4 points that I made clear to you. But if we look at how the teachers do it, then they will normally plan activities with biological, physics, or chemist content. And they talk very much about activities. They do not talk about practical work or inquiry. They talk about activities. So what we are claiming in Method Lab is that instead of talking about activities, they should be talking about practical work with learning objectives within the science content of science and the nature of science. Because what they do is they plan activities, and thereby they are not aware of the method being used, because they are mostly interested in seeing the children manipulating with the things. So this is what we point out, that is already there. It's simply a question of the teachers being aware of setting learning objectives in both the content and the method. And here I've used the term nature of science, because the nature of science has very much to do with the method. The nature of science, I hear quoted from Miller, Robin Miller. The nature of science consists of those seldom thought but very important features of working science: the realms and its limits, its levels of uncertainty, its biases, its social aspects, and the reasons for its reliability. That's to say, the method. How do you know it? How did you find an answer to this? Because that is what that's the take-home message in Method Lab, is that when you ask children after an activity, what have you found out? Then they would say, we have found out that hot water can only contain so-and-so this much salt. Okay, that's good. And then the next question should be, how do you know that? How did you find out? So they are aware of, did they do the survey several times, or did they just simply look it up, or what did they do? So being aware of the nature of science, the way science works. And it has also got to do with learning science as learning to talk science. So we need the pupils to be talking about, to be explaining, how did they work? How did I find out this and that? Not only what do I know. And that's also a message, I think, for you here today, being a scientist and maybe visiting schools. There can be a tendency of such a visit being about what the scientists know. Now he or she will explain everything about the solar system, but it can be equal important and interesting for the children to know, how do you work? What do you do? And do you work by yourself? Because normally scientists, they will work together in groups. So they can work on many hypotheses at the same time, or work with different methods in order to get a sound as a result as possible. So we need to talk about what we are doing. because it has got to do with scientific literacy. Because right now until now I have been talking about science in a sense where science is more important than the life of the students. I have more or less been implying that every child should want to become a scientist, and that is of course not true. As it was also said in the beginning, may the child leaving school, whatever he or she will do in their career, but may they be aware of the role of science, be scientific aware, have scientific literacy, even though they just want to become hairdressers. It's important to have scientific literacy. Scientific literacy is coined in the United States, and it's about understanding, experiment, and reasoning, ask and find out answers, describe, explain, read and with understanding articles, identify scientific issues underlying national. No need for going into that, because Svein Sjöberg, a Norwegian didactiker, he has put it into 4 bullets. Why do we need to teach science in schools? And why do we need to teach scientific method in school? And what he points out is science in school is important for economical reasons. We as society need scientists. That's obvious. Science is important for practical reasons. One meets challenges every day that demand scientific knowledge and skills. Handling your iPhone, handling your power sockets at home, figuring out why the fridge doesn't work. All sorts of practical problems that demand a scientific approach to be solved. Science is important for democratic reasons. As citizen, you are supposed to make decisions for your life involving scientific knowledge and skills. Should I eat this? Should I eat this? Is it okay for me to drive a car, or should I rather take the bus? All sorts of profound decisions we are supposed to be doing, and we are also supposed to give reasons for why we choose to do this and that. A friend of mine has just given birth, and she felt very much that she was supposed to make all sorts of decisions of her being pregnant and be responsible to the whole world, because they were asking her, is it safe for you to eat this now you're being pregnant, and shouldn't you take into consideration, and have you read this, have you read that? So it's not enough simply to rely on what your mother did. You need to be scientific aware that there are some risks that you need to know about. And this entails the 4th point here. Science is important for cultural reasons, because science is a major part of our culture and forms part of the decision-making in society. Of course, that's an ideal that scientific explanations will always underlie the political decisions. But still, when in Denmark a new law is being proposed, then they would ask, why is it a good idea? And the answer would be, experts tell us this and that. So we have a cultural bias towards the scientific explanation, and even pseudo-scientific people use the scientific language in order to gain some understanding. It can be scientifically proved that numerology is good for you. So even though numerology has got no scientific proof, numerologists may use a scientific way of presenting their ideas, so it will make us believe it. And this is actually what this part here is what excites the Danish teachers I have met the most, because that is where science and humanistics meet, because it has got to do with reasoning, and I think Maria will be telling you more about that, because at some point you could say that if I was considering divorcing my husband, I could ask my sister, should I divorce him? And she would ask, what have you seen, and what has he said? And oh, he has been away every weekend for a year. You should definitely divorce him. And that's only on her, founded on her beliefs and her experience. But if I ask a sociologist, should I divorce my husband, I think the sociologist would ask me, how old are you? How long have you been married? Do you smoke? What is your income? And then we can put it into a spreadsheet, and they make a prediction of other people like me in my age. How likely is it that I would be divorced? So that's a scientific explanation based on data. It's not decided. The answers to me is can have the same relevance, but it's two very different ways of finding an answer to a question, and the one being scientific and the other being social or being familiar. And it's crucial that pupils are aware of what is the strength in the answers given. You should do this. Okay, how do you know? Because I say so. Not good enough. How do you know? And in times of crisis, it's even more important to make sound judgments on your own and not just to follow a trend. So how do you know that? So how should we regard practical work in school? Teachers want to do practical work, and practical work is indeed important in regards of scientific literacy and the nature of science. And the central aim of science is to explain the observed behavior of the material world. So what we have in practical work is that we have a domain of objects and observables. That can be a table and the water and the sky. And then we have the domain of ideas, the concepts. Take, for instance, the water cycle. The water being passed around in the atmosphere. The names we give water, that's ice, and it's a fluid, and it's a damp or a cloud, and I don't know the English words for it, but you can imagine all the words we apply on what's happening to the water when it circulates from beneath our feet and up to the sky and down again. These concepts are man-made, and all the concepts in science are, in fact, when you come down to it, they are man-made. And I feel it quite strongly when I teach at the aquarium, because if I have a group of pupils in front of an aquarium, and I ask, what do you see? And I think it's obvious that they will see a shark. But they say, oh, I see a huge coral. I see a lot of water. I don't see anything. I see the color blue. So for me, it's so obvious that what they should see is the shark. They see a lot of other things. So for them to see what I want them to see and to use the right concepts and the right words for it, that can be done through practical work, but it needs to be discussed. Oops, let's come the other way around. I don't have time for this, so I'll jump through this. Sorry. You can have my slides if you want to. So my finishing line, is what I have already said, that we need to set learning objectives for the lessons taught, and that they should be found both in the scientific content and in the scientific methods. So we are dealing with aspects of the natural world, and we are dealing with the aspects in a certain way. So how are we working with water today? Are we doing experiments? Are we just making observations? How are we working with the content? And we use this model in the teacher courses. It's also from Miller. And it's very simple, but I find it quite powerful, because what you can see is here, teachers' objectives, what the students are meant to learn. And down here, learning outcomes, what the students actually learn. And this is what you can test in an exam or in other tests, or simply at the end of the day, did they learn what they were supposed to learn? But what Miller does is that he adds this one, task specification, what the students are meant to do. So not so much what am I as a teacher meant to be explaining or showing, but more what are the students meant to do. And in Miller's sense, it's both what are they meant to be discussing, what words do I want to hear come out of their mouth, and what are they meant to do with their hands, how should they manipulate things. So this is a way of looking at the practical work. Is it efficient or not? Because my teachers at the aquarium, they would say them, I set the learning objectives and they didn't understand a bit of it. So they were stupid. And I said, what did they do? Yeah, they didn't do anything. Oh, so perhaps they didn't understand the task. But the task is so easy. They're stupid. So always making explanations about the pupils not understanding what to do. And I try really hard to emphasize, you need to be specific about what they are supposed to do. And then pay attention. Do they do it? Or do they do something else? Do they misunderstand what is supposed to happen? I can give you a very brief example. We have a theme called habitats. And we have 3 different fish, one living at the bottom of the sea, one living in the free waters, and one living in the surface of the water. And you can tell quite easily by how the mouth is pointing. Is it pointing downwards, this way, or this way? So you can tell, when you know, you can tell quite easily where does the fish live. And the idea is that the children need to discuss, our fish, is it a bottom living fish? Yes, it is. And then they are supposed to make an aquarium that will fit this fish. And they are giving all sorts of supply. This is something my colleagues have been working on, and I have now thrown it away. Because what happens is that you ask, first, you have a learning objectives about where does the fish live. Okay, interesting. The children get the grasp of it. Then we say, now you build an aquarium to your fish. And then they all start building aquariums as they know they look like. Can we have a diver? We need to have this small treasure box in the bottom. And they fill the aquarium with all sorts of things, because it's not obvious for them that they should make any other aquarium than what they already know an aquarium looks like. So what they do is they do something, in our sense, completely wrong, but it makes perfect sense for the children. They are making an aquarium. And it's only us arguing that a fish living in the surface has no need for plants. Stupid, there must be plants in aquariums. Everybody knows that. So, back to this model. When we combine real science and school science, then I would argue that this model is a good way of looking at it, because real science has got very little to do with what's going on in school. And we can try and implement aspects of real science in school, but we can also, for the benefit of the children, divide the investigation into manageable methods, so they understand how they are working. And that's beneficial for the pupils in the sense of scientific literacy. They understand how is scientific knowledge produced. It can be produced in different ways. And it's also an advantage for, I would argue, for the science community, because if these children choose to move on to become scientists, then they would have a good idea of how to discuss your results. And one example we used in the Method Lab is the climate provocateur, Bjørn Lomborg. I don't know if the name rings a bell, but he's a Danish scientist within economics, and he had very strong views in the 90s and beginning of 2000 that climate changes were all bollocks, and he had some very strong views. And what the scientific world did was they did not discuss his conclusions. They were always discussing his method. You can't apply economic theory on climate. Are you stupid? You can't use that investigation method. So that was difficult for the public to see that what the public were asking, do you disagree with Mr. Lomborg? And then the scientists would say, I don't disagree with him, but I disagree with the method he has been using. So in that sense, putting methods in the foreground is beneficial for both children growing up to become whatever they want, and for them to become future scientists. So that was all I had on. Oh, I spent 2 minutes too much. I'm sorry. Thank you.
Muchas gracias por tu charla. Hemos pensado, por si habéis visto el programa, de hacer las preguntas al final, después de la siguiente ponente, porque en realidad están muy relacionadas las dos ponencias y porque nos parece interesante tener un espacio de diálogo al final. Entonces, si os parece, vamos ahora al descanso. Tenemos aquí un café fuera y cuando volvamos vemos la charla de María y tenemos un espacio para debatir y discutir y preguntarle todas aquellas cosas que seguro que le queréis comentar a Sara en su excelente ponencia. Muchas gracias.